Hello, in this video, I'm going to show you how to do the statistical analysis for our statistic project. We collected two samples from two populations, and then the three data that we collected. One is the categorical data, how affected you are by COVID-19. We summarize it as counting the number of success as strongly affected. For the college student sample, we have X1 equal to 8, N1 equal to 28. And for the non-college adult sample, we have X2 equal to 6 and 2 equal to 22. And the sample proportion is 28.6% for college students sample, 27.3% for the non-college adult sample. So they're pretty much the same, 28% to 27%. So the requirement for our statistical analysis is for the categorical data, look at the proportion difference. The sample shows that they're almost the same. So what is the actual population proportion difference for people that are strongly affected in the two populations? And because we are doing proportion and it's two samples, so we will use two prop C interval. Okay, so we'll construct a 95% confidence interval. So do stat test two proportion interval, Z interval. So x1 is 8, x2, n1 is 28, x2 is 6, and 2 is 22 for me. And then my C level is 95%. So the lower limit is negative 0.237. Upper limit is 0.263. So that's what I'm going to write down. So from the calculator, the output is negative 0.237 less than P1 minus P2. This is the difference of the two proportion, 0.263. We can summarize it a little bit. We can say we are 95% confidence that the difference, so this is about difference, in proportion of people being strongly affected by COVID-19 for college students and non-college adults are between 23.7% to 26.3%. That's a really big difference. So and so that's the conclusion from the confidence interval, 95% confidence. And because 0 is in the interval, we do not have sufficient evidence to conclude there is significant difference between the two population proportion, between the two population proportion. It is likely that the two population proportions are the same. And we can confirm by the sample. So the sample shows that they're just 1% apart, and the results show that they are more or less the same. Not sufficient evidence that there is a significant difference. They're pretty much the same. So the second hypothesis would be, the second is to do a hypothesis test. This is what I have chosen, that college students stay home longer than non-college students on average. And I want to use a significant level of 0.05. So earlier when we do the data summary, we look at this page. We already calculate mean, standard deviation, and sample size for population 1 and 2. So we'll just gather them here, put them here. Population 1 is college student, x1 bar, S, and 1, x2 bar, S, and 2. Just put them there. And then we have to translate the claim into a symbolic form. This is about measurement, so we do mean. Mu1 is, what would you say, college students stay home longer. So we would say greater than mu2, right? That's the claim. So the stay home number is longer. But if you look at the sample mean, actually college students stay home less. It could be because of those outliers, actually. So X0 would be they're the same, right? We always assume that temporarily when we do calculation, they're exactly the same. And then X1 would be the claim. X1 is mu1 is equal to mu2. Or the alternative hypothesis. So then we are ready to do our test. It is a write-out test, and we'll use a calculator to sample t-test because we do not know sigma. So look at our calculator, clear whatever that we have, stat test, to sample t-test. We use statistic. Summary, so we do 3.9, 2.1, 28, 4.7. This is not going to, I don't think the conclusion would be it is greater because even the sample shows that it's less than that. And then N2 is 22, 3.9, 21, 28, 4.7, 2.9, 22. So scroll down. Oh, we have to do a greater than, right? A right-tail test and put it not equal to 0 because we don't know. And then here. So our test statistic is negative 1.09. Our p-value is 0.858. It's really 8584. So it is really big, and you can tell that it is not going to be supported. The claim is not going to be supported. So result would be test statistic. T is negative 1.08. No, 09. P-value is equal to 0.8584. What should the conclusion be? P-value 0.8584 obviously is greater than 0.05. So we say fail to reject X0. X0 seems to predict this kind of sample. So, and then the conclusion is there is not sufficient evidence to support the claim. The claim that college students stay home longer than non-college students. Oh, non-college adults. Not sufficient able to support. So our claim is not. So they're mostly, they could be the same. Or they could be the other way around. Just the things that we want to do is do test for linear correlation for non-college adult stay-home duration and predicted shelter-in-place lifted time. So look at the scatter plot that we have earlier. Here, both of them are pretty, low in correlation. There is not particularly pattern, but for college students, it's like almost close to 0. So there's no way that there is a linear correlation. But for non-college adults, the match pair data seems to show a decent R, 0.3204. So let's do a linear regression test if there is actually linear correlation. So use this. So to do a linear regression test, we can do X0, row, insert, we have to say row equal to 0. And then H1, or alternative hypothesis, is not equal to 0. So meaning X0 is no linear correlation, H1 is there is linear correlation. So do a non-equal. And this is usually what happens. Now, if we want to do the linear correlations, really a hypothesis test that would involve putting the data into calculator and I don't want to do that because there's a lot of data. So what we can do is we would use, but R is equal to 0.3204, right? So we would just use the A6 table. How many data do we have? We're doing the non-college adult stay-home time. Non-college students, how many data do we have non-college adults? 22. So we'll say n equal to 22. Let's do alpha equal to 0.05 by default. So look up the A6 table. 22, right? So there is no 22, so we just use the lower one. Round down to 20, 0.444, right? Alpha equal to 0.05, 20, 0.444. So look up the user table. So CV is equal to 0.444. So it's just save more time. Otherwise, you have to enter all the data to do a hypothesis test for p-value. The A6 tables is more simple. So is it greater? So no, the absolute value of 0.3204 is less than 0.444. So what it do is it conclude no linear correlation. Not enough, there is not sufficient evidence. That means the sample does not show enough evidence that there is correlation between non-college adults stay home duration and predicted shelter in place lived time. Because they are kind of quite related, but it doesn't exceed the threshold, so there is no correlation. I think in both cases there's none. So that's what you need to do for the 3 statistical analysis. You can use the calculator to do the first 2. The third one, you use A6 table.